graph absolute value equations, take this time to ask for some help.
It feels like we have like a break, so I'm rusty. Absolute values are easy. That's a straight B. Yeah. B. So I guess what it looks like.
We just went over it too.
So log green.
Okay, and if you guys have colored pencils or highlighters, that might be helpful for today. If you don't, no biggie.
Number 2
The right side of the function fits on it nicely. The left side, not so much.
Like a Nike check. Bro, it's rise and run.
It's really bad. Okay, sounds like we're done, so let's move on. The first one has a vertex at 2, guys, at 3, 2, negative 2, so let's plot it in the right place, 3, negative 2, and then our moves are over 1, up 1, unless there is a stretch or compression, and there's not in this case, so let's go ahead and graph that function. Alright, let's take a look at the second one. This one has a vertex at negative 5, positive 4. And it's reflected, so it's opening down. And you're right, there's not much to the left side, but we can get a good portion of the right side on there. So we will graph this opening down. We're going down over here. We're going down over here. Okay? And finally, this one starts off on the y-axis, and this is 1/3. So we'll go up 1 over 3 in both directions. And one more time, so we can draw a nice raise. Right side, left side. Okay, so this is the old stuff. This is the stuff we already know how to do. But today we're going to look at absolute value in a slightly different way. Instead of looking at it as one function, we're going to look at pieces of 2 different lines. Okay, so where could I draw in a vertical line that would break this up into 2 lines? Straight down at the vertex. Well, this one would be straight down at the vertex.
Yeah.
And this one would be straight down at the vertex. Okay, so for each one of these absolute value functions, we can divide them up into 2 rays if we break it up right there through the vertex. So now I'm going to color them different colors. We have a ray on the left. I'm going to color that one green. 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 Okay? And now we have a ray on the right. Guys, could y'all please be respectful today? A ray on the right. And I'm coloring mine in pink, but it kind of comes out purple. All right, so if you have colors, you might want to color with me. All right, so I made the left side green for each one of mine and the right side pink. And now if we look at it, it's a line, a line, a line, a line, a line, a line. Okay, so we know two things about lines. The first thing we learned about lines was to write them in slope-intercept form. That was the first thing we learned about lines. So slope-intercept form is y equals mx plus b. And then a little later on, we learned about point-slope form, which is y minus y1 equals m times x minus x1. So if we can see the y-intercept clearly, then this is our best choice, y equals mx plus b. But if we cannot see the y-intercept, then we'll go with choice 2, point-slope. All right, so this is always choice 1, but choice 1 only works when we can see that y-intercept. If we can't see it, we're going with point-slope. Okay, so let's look at this first ray here, the left side. This is a line, so we will use y equals mx plus b. And you can see the y-intercept. So on this one, we know the slope is down 1, right 1, down 1, right 1, down 1, right 1. So this would be y equals, and I'm actually going to put a big y equals out here. Y equals, my slope is down 1, right 1, which is negative 1, x, and my y-intercept is plus 1. Now, generally for a line, our domain is from negative infinity to positive infinity. But this is not a line, it's actually a ray. The green side is a ray. It goes forever left, and it goes right, it stops right here. So we could describe that as an interval forever left, and then going right, it stops right here. What is the x value right here?
3.
3. Or we can write that as an inequality. How would this interval be written as an inequality?
Is that a bracket?
X is less than or equal to 3.
Somebody said less than or equal to what?
3.
3. X is less than or equal to 3.
Why would you not do like the...
Okay, I said you could write it as an interval or an inequality, and you need to be very comfortable with either form. You need to know that this means this, and that this means that. Be able to go back and forth.
I thought you would have done like what we did yesterday, where you put a number, then X, and then another number.
And we do that when there is a starting point and a stopping point. And this one was a forever and a stop. Yes.
Is that a bracket?
It is a bracket. Now, I chose to include the 3 with the green one.
Okay.
So do I get to include it with the pink one? No, I don't. I get to pick. Do I include it with the green or with the pink? But not both. So I could have included it here, which I did. Or I could have chosen to include it with my next ray. So one of them will have the equal to and the other will not when they share a point. Alright, so let's do the pink one. Up 1, right 1. Up 1, right 1. Up 1, right 1. The slope is positive 1. Now when the slope is positive 1, you don't really have to write positive 1. We don't have to write anything. It's 1.
Yeah.
Now, currently, I cannot see the y-intercept. But would it be really easy to just kind of continue it to figure out what the y-intercept is?
Yeah.
Yeah. So we're really sticking with that choice 1 here. We can still do it this way because when we continued it, it fit on the graph nicely. And we see it's down here at 1, 2, 3, 4, 5. The y-intercept would be negative 5. But it doesn't go all the way there, does it? So we have to restrict it. Where does it start? At 3. And it goes forever to the right. Or we could say x values that are greater than 3. Yes?
Why don't you use a bracket for both?
Okay. I chose to use the bracket on the left side. I included this point with the green part. So since I included it with the green part, I do not include it with the pink part. And I get to pick. You get to pick. So you could include here and not here, or not include here and include there. So the equal to can either be here or here, but not both. Yes, ma'am.
How is the equation x minus 5 if it's like a ray and it starts at 3 and goes forever? Like, if that's not real, how is that the equation? Like, does that
Okay,
make sense?
so it does. How do I get to use this negative 5 if it's not part of this?
Yeah.
Okay, so what we could do is we could kind of use this second part and say, all right, I know my slope of this line is positive 1. Positive 1. And I know that it passes through, let's pick a point that it passes through. How about this one right here? We know it passes through this point. Do you see that it goes through that point? So 1, 2, 3, 4, 5, 6, 1. 6, 1. So this equation, you can definitely tell represents that line. Now watch what happens when I simplify this equation. Do I get the same thing? So this ray is this line, but what happens is we have to say we can't do this part of this line. And how do we tell them we can't go on this side of this line? Right here. This domain restriction says you're not allowed to come down here. All right, the next one. So here we have, oh, guys, I want to tell you one more thing about point slope. When we first learned about point slope, we didn't understand transformations. We really didn't understand shifting left, right, up, down, reflections, any of that stuff. Do you see how point slope, the second method, is just transforming a line, shifting it? Just like what we did right here. We did the slope of a line are our moves. And then we transformed it, we shifted it. Right 6, up 1. Right 6, up 1. So point slope is basically the transformational form, just like vertex form is for a quadratic, just like vertex form is for an absolute value. It's the transformational form. It shifts it away from the origin. Okay. The second one. Let's look at the left side. We're going to look at that left side first. So I'm going green again, because I colored mine green. If I look at this slope, it's up 1 over 1. The left side of this equation is positive 1. I really shouldn't have connected these. These don't really go together. This should have been just like a big old fat line in between these. That way you can tell this goes with that one, that goes with that one, that goes with that one. So, we're going to write the two equations here. And this left one, the slope is up 1 over 1. So the slope is positive 1. And the y-intercept is not going to fit on my graph. So let's go back to this transformational form and see if we can figure out the y-intercept. So we know the slope is positive 1. So if I did y minus y1 equals the slope times x minus x1. And then let's just pick a point on that line. How about this point right here? That point is negative 1, 2, 3, 4, 5, 6. So negative 6 is my x, which makes a plus 6. And my y is 1, 2, 3. So if I simplify this, I get x plus 6, y minus 3. And when I add 3 to both sides, I get this left side is y equals x plus 9. So I couldn't see the plus 9. But that's what the y-intercept would be if I got to graph the whole thing. But I don't get to graph the whole thing. I only get to graph from right here left. So my domain would be negative infinity to this x value, negative 5. Now, do you want to include it this time with the green line? Or do you want, okay, let's include it with the green line then. So this is what it looks like as an interval, and this is what it looks like as an inequality.
If you didn't include it, you just wouldn't have equal to it.
Correct. Yes.
Why is it y minus 2?
Okay, so point slope form is always y minus the y value equals m times x minus the x value. So with this point right here being the point negative 6, positive 3, it's y minus 3, x minus a negative 6.
So it switches.
It switches the signs, yes sir. Yes,
Why did you plug in 1 to the slope?
because on the green side,
Positive 1.
you go up 1, right 1, the slope is 1. Okay? Now let's look at the pink side. Down 1, right 1, down 1, right 1. The slope is negative 1. And this one we can actually see the y-intercept. Much easier when we can. Minus 1. And this would be for all the x values that are greater than negative 5. Or from negative 5 to infinity.
But it wouldn't be a bracket around here.
Because I chose a bracket here, I won't do it here. So in the third one, I'm going to do it the other way. I'm going to include it with the right side instead of left, just so we can see they both work. Now, number 3 is actually the easiest of all. Because the vertex is on the y-axis, we can see the y-intercept for both sides at once. So we know the left side, the slope is down 1, right 2, negative 1/2.
It's 3.
3, negative 1/3, thank you. And the y-intercept is negative 2. And that is from negative infinity to 0, or x values that are less than 0. But then the right side is up 1, right 3, so it's positive 1/3. But the y-intercept is the same thing. Now this time I'm choosing to include it on the right side because I get to make that choice. I can either include it on the left or the right, but not both. Okay. Last night's homework had 1, 2, 3, 4 on the back. These are our U-tries. Okay? These 4 must be completed or you can't get any credit for your homework tonight. No, your homework is that second sheet you picked up today.
I did the, what was that?
And the domain wrong. Because that would be like this. It would fail the vertical line.
I wrote all the equations right. It's just that
The back of class.
I did the domain.
So our homework is this.
I'll tell you what your homework is in a minute.
Oh, yeah.
You're right now those 4. The back of last night's homework is like this stuff.
Oh, is it like, oh, yours is like up here because we're covered. It's
All right, if you're watching this video, open up the notes page and you can see the answers to these.